Yeah, it's recorded now. So we are going to solve this question by using these formulas. Understand, my dear? So please, my dear, when you are about to solve the question from this chapter, you should be very, very careful about each and every word. Understand?
Doctor,
Yes.
can you zoom to the formulas? I want to take a picture.
My dear, this will be recorded. Just don't worry.
Yes, but I want to solve the problem.
Is it okay?
Yes, thank you.
Okay. So, my dear, read the question. Read the question very carefully. What is given here? So, we are going to read the question line by line, word by word. It's very, very important. Could you please read the question? What is given in the question? Excuse me, my dear, it's my kind request. Please don't message your friends. If you have any question, ask me. Because always I'm hearing the typing sound, and then whenever you send the message, I hear the sound. Please try to avoid that. It's my kind request.
Doctor,
Yes.
he said don't hear anything from you.
You didn't hear me anything?
Just
No, we can hear you, but some student can.
So if they have issue, they have to log out and log in. I can't do anything, my dear. I think everybody.
Now
Is it clear?
Yeah.
Okay, that's good. That's good.
Okay.
That's good.
Okay.
Okay. So, my dear, read the question. What is given in the question? When 0.
When
Yes.
0.43 mole of oxygen.
Okay. Just listen. When 0.4 moles of oxygen gas, my dear, you can just see this oxygen. What's the formula for oxygen? What's the formula for oxygen? What is written here? O2. Am I right?
Yes.
O2
Yes.
is the diatomic or monatomic?
Diatomic.
So the type of the molecule is given. So it's a diatomic molecule. Am I right? Am I right?
Yes.
So you have how many moles? I have 0.4 moles of oxygen atom. So oxygen is a diatomic particle. And what is the condition? What condition is given?
Constant pressure.
So constant pressure. So you have to use this value. Am I right? So
Yes.
what is the starting temperature? The starting temperature is given. What is the starting temperature? 0 degrees Celsius. You have to convert this 0 degrees Celsius to Kelvin. So if you convert to Kelvin, what you will get?
27.
Very good. So you are going to calculate the energy. So condition is given, which is nothing but the constant pressure, and the type of the molecule is given. It is diatomic molecule. From the formula, we came to know these things. It is a diatomic particle. And how many moles you are going to take? 0.4 moles. And what temperature they give? The initial temperature is at 0 degrees Celsius. So if when you convert to Kelvin, this becomes 273 Kelvin. Now what we are going to do? We are going to find what should be the energy. So when you find the energy, they clearly mention. What is mentioned here, my dear? Listen carefully. This word is very, very important. How much energy must be added to the gas as heat to triple its volume? That means initially what is the volume? Initially the volume is 1. Am I right? Am I right or not?
Yes, you are right.
So when you heat, what happened? Its volume is increased from 1 to
triple.
3 times. Am I right? So my initial volume is 1. What is my final volume?
3.
3. So we are going to find this Q. We know the formula. What is the formula, my dear? You can see here we have two formula for constant pressure. This will be the rule. Am I right?
Yes.
So I am going to use this rule. So please listen carefully. We are going to do some mathematical trick also. So Q, which is equal to NCP delta T. My dear, this is Cp and this is a constant pressure. Constant pressure, diatomic molecule. What should be the value of Cp?
7 over 2R.
So you have to write n multiplied by 7 over 2 times of r. And what is the delta t? Delta t is nothing but t final minus t initial. Am I right?
Yes.
Yes.
Okay. Now, my dear, listen carefully. We have all the information. N we have, R is the constant value. So no problem. We will give that value. Initial temperature is given. Is there any information about the final temperature?
No, Doctor.
No.
No.
So I am going to do some mathematical trick. What I am going to do, my dear, listen carefully. This step is very, very important. I am going to use some mathematical trick. So n 7 over 2 times of r. What I am going to do, in the top and the bottom, I am going to multiply by ti. Clear? Clear, my dear? Clear?
Yes. Yes.
So if you multiply with our ti, if you divide by ti, your equation will not alter. Am I right? It's exactly the same. Am I right or not?
Yes.
Yes.
Now what I am going to do, I am going to take this denominator, I am going to multiply this denominator inside this bracket. If you multiply, what you will get? Your equation becomes n multiplied by 7 over 2 times of r, and the top ti I am going to keep as it is. I am going to multiply the denominator ti inside the bracket. So what you will get? Your equation becomes like this. Am I right?
Yes.
Yes.
Clear? So now ti divided by ti becomes 1. Am I right?
Yes, you are.
So I got ti, and inside the bracket tf divided by ti minus 1. Am I right?
Yes.
Now if you just read the question, in the question they give the information about the initial volume and the final volume. Am I right or not?
Yes.
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 So what I am going to do, I am going to try to convert this value. I am going to try to convert this value in terms of V final and V initial. My dear, for that what I am going to do, I am going to write the ideal gas equation. So better I can just use this my first equation. I am going to take this is my first equation. Understand? Okay, now what is the ideal gas equation?
PV equal nRT.
So I can write that PV is equal to nRT for initial as well as the final. So my dear, listen carefully. P initial, V initial, which is equal to nR T initial. So I am going to take this my first equation. I am going to write the same equation for the final also. What is the final? P final, V final, which is equal to nR T final. Am I right?
Yes.
Clear? I am going to divide 2 by 1. So I am going to divide the equation 2 by 1. So if you divide, what you will get, my dear? If you divide, what you will get? You will get in the left hand side, you will get PF VF divided by PI VI, which is equal to nRTF divided by nRTI. Am I right?
Yes, you are.
What condition is given in the question? What condition is given in the question? What is the meaning for constant pressure, my dear? What is the meaning for constant pressure? Your pressure is constant. Am I right?
Yes.
Am I right or not?
Yes.
So if your pressure is constant, your initial pressure must be equal to final pressure. Am I right?
Yes. Yes.
So this pressure get cancelled. Am I right or not?
Yes, Doctor.
And here we can cancel this n or both top and the bottom. Am I right?
Yes.
So what is remaining? We have V final over V initial, which is equal to T final over T initial. Am I right?
Yes, Doctor.
So my TF over TI, which is exactly equal to
VF over
V-
VI.
So my dear, listen carefully. I am going to take these. I am going to substitute here. Understand?
Yes.
So if you substitute, how your equation becomes? Your equation is becoming Q, which is equal to N 7 over 2 times of R multiplied by Ti inside the bracket. My TF over Ti become VF over VI. Am I right?
Yes. minus
Now
1.
you can see you have the information about the number of moles. Am I right?
Yes.
Dr. R equal to how?
R is the constant, my dear. This will be given. So R is equal to 8.314. This is a constant value, gas constant. So don't worry about this value. Okay.
Okay.
So what is your initial temperature? Initial temperature is given in the question. What is your initial temperature? 273. Am I right?
Yes.
What is your final volume? Your final volume is 3. Am I right?
Yes.
What is your initial volume? It is 1.
1.
So you have all the values. When you substitute the value, you will get the answer. Am I right?
Doctor,
Yes, my dear.
if I did it directly,
How you did it directly?
I mean, if I did TF over TI, I didn't do what you
My
did.
dear.
DV equal
Okay, my
nRT.
dear, if you want to skip the steps, no issue. But you must know what you did here. Am I right? So we replace this T final over T initial by using the ideal gas equation. Understand?
Yeah, okay.
If you write the equation, no issue. But if suppose if you ask how you convert, then you have to give the proof. Am I right? As a teacher, I have to
Yeah.
explain. Am I right or not?
Yes, right, Doctor.
So that's what I explained. Understand, my dear? So you have all the values here. When you substitute, you will get the answer for the first question. Understand?
Yes. Thank you.
Okay. So now let's we go for the second question. What is given in the second question, my dear?
Excuse me, Doctor.
What is the sound? Do you hear me?
Teacher, yeah. Teacher,
Okay.
I just
Because
have
I'm
one.
hearing.
I just have one question.
Yes. Please ask your question. So
Yeah,
please ask your question. No issue.
My question is about the CV and CP. How did you chose it? How did you choose it?
Because the constant pressure, if you got the word
Yeah.
constant pressure, it represented CP. Okay. If you have
Okay, this
constant
one.
volume, if you have constant volume, it is
CV.
keep this information. Understand?
Okay, this one I get, but why did you choose the 7/2? Like DA,
Because
MA,
you can
PA?
see, my dear, you can see this. You can see this. You can see this. This
Yeah,
is for
okay, I get it.
monatomic, diatomic, polyatomic. For CP, what is the value for diatomic?
Oh, okay, now I get it. Okay.
Clear?
Yeah.
Okay. Is it clear?
So, Doctor,
Yes.
you did these steps and you used the general ideal gases because we don't know TF. If it's known, we can put it directly.
If it, my dear, in the question, if the final temperature is given, no need to go for this step. You can directly substitute the value here and get the answer. Understand?
Yes.
Suppose if the final temperature is not given, then you have to convert that in terms of volume. That's what we are using these many steps. Clear?
Yes.
Okay. So let's we go for the second question. My dear, I need the answer from your side. So please read each and every word. What is given in the question? Suppose 2.8 moles of an ideal diatomic. What type of gas they give? What type of gas?
Atomic.
Diatomic. And they clearly mention what is the condition?
Constant pressure.
Temperature.
Constant pressure. That means what is that?
CB.
CP.
CP. So please keep this information. Understand? Okay. So what is our moles? Our moles N is equal to 2.8. Am I right?
Yes.
What type of molecules we are having? We are having diatomic. Am I right?
7/2R.
What is the condition? Constant
7/2R.
pressure. Am I right? And then you have the change in temperature also. So temperature increase of means what they clearly mention? They mention the information about change in temperature. What is your change in temperature, my dear?
45.
45 Kelvin. Now you have 4 questions. What is your first question? What are the energy transferred as heat Q? So if it is constant pressure, what should be the formula, my dear? We have used the formula N Cp delta T. Am I right?
Yes.
Yes.
What is the Cp for diatomic molecule? Just before we saw here, Cp for diatomic molecule is exactly equal to
7/2.
7/2.
7/2. So I have to use 7/2 here. So if you just work out here, what you will get? N N multiplied by 7 over 2 times of R is the constant, and delta T is already given in the question. When you substitute the value of N, when you substitute the value of the constant, when you substitute the delta T, you will get the answer for the first question. Am I right?
Yes.
Am I right?
Yes.
Okay. What is your second question?
Doctor.
What is your second question?
Doctor,
Yes.
R is equal to 8.3.
My dear, R is the gas constant. This value will be given 8.314. So don't worry about this R. It's a constant. Understand?
Yes.
Oh. Okay. What is your second question? What is the change in internal energy? My dear, what is the formula for change in internal energy? Go back to the formula. What is the formula for change in internal energy? This is the change in internal energy. Am I right?
Yes.
Yes.
So what formula? We have N CV delta T. Am I right?
Yes.
So what is the CV for diatomic molecule? What is the value for CV for diatomic molecule?
5 over 2R.
When you are finding the internal energy, there is no formula for internal energy with the CP. So internal energy always have CV. Understand? So my change in internal energy, which is equal to NCV delta T. So the value for CV is exactly 5 over 2 times of R multiplied by delta T. Now you can see N value is given in the question, R is the constant, delta T is given in the question. When you substitute, you will get the answer for the second question. Am I right?
Yes, Doctor.
No.
But in this question, they clearly mention pressure constant.
Pressure constant, but they are asking about internal energy. Internal energy, there is no constant pressure. Internal energy is only applicable for constant volume.
Yes.
Yes,
Right.
yes.
Clear?
Clear.
Yes.
We don't have any formula for internal energy with constant pressure.
Clear, Doctor.
Okay, what is your third question, my dear?
The work.
What is the third question?
So
for finding the work done, my dear, you have to use, for finding the work done, we have to use the first law of thermodynamics. What is first law of thermodynamics?
work
Q, which is equal to change in internal energy plus work done. Am I right?
yes.
Yes.
Therefore, work done, which is equal to Q minus change in internal energy. Am I right?
Yes.
Yes.
So now you can see from the first part, you will get the information about the Q, and the second part, you will get the answer from the delta internal energy. When you substitute the values here, you will get the answer for the third one. Am I right?
Yes. Doctor, why don't
Ah.
use because the constant pressure no no it's for volume. Yes, I'm wrong. Completely
Clear?
clear.
Okay. What is the fourth question, my dear? What is the fourth question?
The change.
The change in kinetic energy for total translation kinetic energy. My dear, go back to the formula. You have two formula for the kinetic energy. Am I right? One is for average, another one for total. Which formula you are going to use?
Total.
That means we have to use this one because they clearly mention in the question. They clearly mention in the question about
Total.
what they clearly mentioned in the question.
Total.
Total. So total kinetic energy, which is equal to 3 over 2 times of N R delta T. Am I right? Am I right or not?
Yes.
When you substitute all the values, you will get the answer for the fourth part. Am I right?
Yes.
Clear?
Clear, Doctor.
Okay. Now, third question. What is your third question, my dear? Read the question very carefully. What is your 13th question? The speed of 11 molecules are given. Here you have 11 molecules. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Up to 12 you have. How many molecules are here? 11 molecules. What are the things you are going to find? You are going to find average speed, and also you are going to find RMS speed. My dear, average you already know. How to find the average speed, my dear? Speed average, just find the average. How to find the average? How many molecules you have? How many molecules you have?
11.
11. That means 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. Am I right? So when you just add all these molecules, divide by 11, you will get the answer. Am I right?
Yes.
Okay. Now that's not a matter, my dear. Second question is matter. Please read the second question. What is given in the second question? You have to find RMS speed. My dear, I told you already. You have to go in the reverse order. Am I right?
Yes.
Yes.
What is this? What is this? Yes.
Square.
Square.
Square. Then what is this?
Mean.
Mean. Then
Root.
okay. So first of all, I am going to write the number. How many numbers you have? 11 molecules. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Am I right? And then what I am going to do? I am going to square. Am I right?
Yeah.
So squaring all the number. And then what is the meaning for mean? Mean is nothing but average. Am I right?
Yes. Then over 11.
So I have to add and divided by
11.
11. And then finally, what is this? Finally,
Take the root.
Square root.
you have to take the root for the entire digit. So you will get the answer. Am I right?
Yes. Very easy.
So please, my dear, if you got these type of question, don't miss.
Okay.
Understand?
Clear. Yes.
Okay. Now let's become here. So here, read the question very carefully. This question is very, very important, my dear. In many exams, we ask the question, and what is given in the question? A certain gas molecules has occupied the volume of 0.76 liter. So what is the initial volume? What is the initial volume?
0.6.
0.76. And at a pressure, what is the pressure? What is the pressure, my dear? Initial pressure? 1.2 atm. If you convert this atm in terms of Pascal, what you have to do? You have to multiply with 1.01 multiply by 10 to the power of 5. So you will get the answer in terms of Pascal, because Pascal is the SI unit. Understand?
Yes.
Okay. And then what is the temperature? Your initial temperature is given.
Teacher, can you repeat that? How to turn it to Pascal?
My dear, this is the atmospheric pressure value. Am I right? ATM means atmospheric. If you convert ATM to Pascal, what you have to do? You have to multiply 1.01 multiplied by 10 to the power of 5 with that number. You will get the answer in terms of Pascal. Clear?
Yeah, clear.
Okay. What is the temperature, my dear? Temperature is given in terms of 4000 Kelvin, and that is nothing but your initial temperature. Now, we have to read very carefully from here. What is given here? It is expanded adiabatically, and its volume is increased to 4.3 liters. So, what is your final volume, my dear? What is the final volume?
4.3.
4.3. Now, what are the things you are going to find? You are going to find what should be the value for final pressure and what should be the value for final temperature. Am I right?
Yes.
Am I right?
Yes.
And then they give the information about the gamma. What is the value for gamma, my dear? Gamma is given as 1.4. My dear, we have two equations. Do you remember that? Yesterday, when we conclude the chapter, we concluded with these two equations. Am I right? Am I right?
Yes.
Yes.
So by using the first equation, we can find the final temperature. By using the second equation, we can find the final pressure. So I am going to use this equation for this problem. So please, my dear, please recall the formula. The formula is very, very important. What is your formula? Formula P1, that means P initial, V initial, which is equal to P final, V final, gamma here, gamma here. Am I right? Am I right?
Yes.
And what is the second? What is the second formula? T initial, V initial gamma minus 1, which is equal to T final V final gamma minus 1. Am I right?
Yes.
Yes.
Please rearrange this equation. If you rearrange, you will get the answer for PF. Here, if you rearrange, you will get the answer for the TF. So PF, which is equal to P initial V initial gamma divided by V final gamma. Am I right?
Yes.
So I can write this as P initial V initial over V final, the whole power gamma. I can write like this. Am I right?
Yes.
Now you can see initial pressure is given in the question. Initial volume is given in the question. Final volume is given in the question. The value for gamma is given in the question. So you will easily get the answer for the final pressure. Am I right? Am I right?
Yes, you are right.
Okay, let's come for the B part. I'm
Yes,
going
yes.
to find the final temperature. Final temperature TF, which is equal to, rearrange this equation, T initial V initial gamma minus 1 divided by V final gamma minus 1. Am I right?
Yes.
I can
Yes,
write
yes.
this as V initial over V final, the whole power gamma minus 1. I can write this equation like this. Am I right? When you substitute the value, you will get the answer in terms of Kelvin. T initial is given. What is your T initial?
Good. All right.
4000. What is your initial volume? 0.76. What is your final volume? 4.3. And then gamma value 1.4. When you substitute the value, you will get the answer for the final temperature. Understand?
Yes.
Is it clear?
Clear. Yes.
My dear, the most important thing, you have to memorize the equation. Without equation, it's very, very difficult to solve. All the problems are very easy. But the only important thing, you have to recall the equation correctly. Understand?
And hopefully you will give us the paper equation in the exams.
Inshallah, I don't know, but still it is not decided. But we already decided in the meeting, but still the final solution is not coming. Inshallah, once it comes, we will let you know. If it is not come, then you have to memorize by yourself.
Doctor,
Clear? Yes.
let's say that you will give us the exam sheet, the formula sheet.
My
Sorry.
dear, exam sheet, that's what I said. Still, it is not decided. Still, it
Okay,
is
okay.
not
I'm
decided.
saying let's suppose, okay? Let's suppose that you will give it.
Okay.
Would the questions will be changed? I mean, will they be harder?
No, 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 no. How we can ask, brother? We will ask the question from the model what we discussed. So don't worry, it will be very easy.
Okay, okay. Thank you.
Like the
It will
quiz.
be very. Like the quiz, yes, of course.
Some question came from QFUBM.
Really? So you
Yes.
enjoy, huh?
Yes.
Okay, that's good. Okay.
We enjoy for what?
Okay, my
Doctor?
dear. It will be very easy, my dear. Don't lose the hope. It will be very easy. So don't worry. Clear? Okay. Could you please read the fifth question? What is given in the question? The lowest possible temperature in the outer space is 2.7 Kelvin. That means the temperature is given. What is the temperature, my dear? The temperature value is given as 2.7 Kelvin in the outer space. Am I right? Am I right?
Yes, Doctor.
Yes.
What you are going to find? What is the RMS speed of hydrogen molecule in the temperature? My dear, you are going to find the RMS of the hydrogen. My dear, we have the formula here. Could you please just go back to the formula? We have the formula for the RMS speed. What is the formula for RMS speed, my dear? You can just see here. What is the formula for RMS? What is the formula for the RMS?
R3T over
V
V RMS, which is equal to square root of 3RT divided by mass. Am I right? M,
Yes.
capital M, not mass. It's a molar mass. So V RMS, which is equal to square root of 3RT divided by capital M. Am I right? What is the value of R? R is the constant, 8.314. And what is your temperature? Temperature is given. And what molecule they give? What molecule they give?
Q's.
What molecule is given? Hydrogen molecule, am I right?
Yes.
Okay, my dear, listen to the chart. You can just have a look of this chart. For hydrogen, what is the value for the molar mass?
2.20.
2.02. Don't forget to multiply this 10 to the power of minus 3. It is also included. So hydrogen value 2.02 multiplied by
10 to the power of minus 3.
so molar mass of hydrogen, which is equal to 2.02 multiplied by 10 to the power of minus 3. When you substitute this value, you will get the answer. So 3, R value is 8.314 and the temperature is given as 2.7 and divided by the molar mass of the hydrogen is given as 2.02 multiplied by 10 to the power of minus 3. You will get the answer and the unit is clear?
Yes, doctor.
Yes, yes.
Clear.
Doctor,
Okay. Yes, my dear.
what's the difference between this and question 11, VRMS?
My dear, here the temperature information is given. In this question, there is no information about the temperature and or everything. All right, they just give clearly given the information about the molecules only. So here you have to follow this method. If the temperature and the molar mass is given, then you have to go for this formula. Understand?
Yes.
Clear.
This is the only difference.
Okay.
Okay. So let's come for our final problem. My dear, again, we are going to play with the same thing. Just as a read, suppose 1.8 mole of an ideal gas. So what is the number of moles? The number of moles is given as 1.80 mole. And it is taken from the volume of 3 cubic meter to a volume of 5.5 cubic meter. So what is your initial volume? My initial volume is 3 cubic meter. And what is my final volume? 5.5 cubic meter. Understand?
Yes, doctor.
Okay. And what is the type of process? What process they mention?
Isothermal.
Isothermal.
What is the meaning for isothermal? What is the meaning for isothermal?
Constant temperature.
Constant temperature. Isothermal means what? It's a constant temperature. So the temperature is given in terms of Celsius. So you have to convert this Celsius in terms of Kelvin. So what you have to do? You have to add 273. When you add, you will get 303 Kelvin. Am I right?
Yes.
So what you are going to find? My dear, two questions are given. The first question is the numerical type question and the second question is the theory question. So first we solve the first question and then I will give the information about the second question. What is given in the first question? You have to find the value of the heat. Am I right?
Yes.
Right? Okay.
Yes.
Let's go back to the formula. My dear, let's go back to the formula. This is our formula. Am I right? This is our formula. My dear, what is the condition for isothermal? What is the condition for isothermal?
Will be
Change in internal energy which is equal to 0. Am I right?
yes,
Yes.
0.
So I am going to apply this condition here. So now, my dear, you have to give the answer. Could you please recall the first law of thermodynamics? So isothermal means your change in internal energy which is equal to 0. Am I right?
Yes.
Doctor,
Okay.
will be
Could you please recall the first law of thermodynamics? Q which is equal to change in internal energy plus work done. Am I right?
Yes.
Yes.
So if you put it this value here, what will happen? Your Q is exactly equal to
Work
Equal
done.
work done. Am I right? My dear, for this isothermal, we have the formula. Am I right? What is the formula for isothermal work done, my dear?
T0.
We have this formula. We already studied. Am I right?
Then VI over VF over VI.
So we have this rule. Am I right? So my Q is equal to W. So I can directly substitute the formula here. Am I right?
Yes, doctor.
So now you can see you have the information about the moles, you have the value of the temperature, you have final volume, you have initial volume. When you substitute, you will get the answer of Q. Am I right?
Yes.
Okay, now what is the answer for the second question, my dear? It's a theory question. What they're asking, whether the heat is transferred to the gas or whether the heat is transferred from the gas. How you have to say these things? My dear, when you solve the problem, my dear, listen first. When you are workout, after you substitute the value, you will get some number here. Am I right?
Yes.
If you got the positive answer, it means the heat is transferred to the gas. Clear?
Yes.
Yeah.
Suppose if you got negative answer, what is that?
From the gas.
Keep this information in your mind. So maybe I think we got positive answer. Better I can just open the slide. What answer we got? For the last question? We got the positive or negative. I don't know. What answer we got here?
Positive.
Positive.
So what should be the answer?
From the gas.
To the gas. If it is negative, from the gas. Clear?
Yes.
Yes.
So what should be the answer for the second part? The second part is heat is
To the gas.
To the gas.
transferred. Heat is transferred to the gas. Clear? Why? Because we got the positive answer. If it is positive, it is transferred to the gas. If it is negative, transfer from the gas. Keep this information. Understand, my dear?
Doctor,
Yes.
can you repeat A quickly?
Okay, my dear. They clearly give us the information about isothermal. Am I right?
Yes, doctor. Yes.
Isothermal condition. What is the condition for isothermal? Your change in internal energy is equal to 0. Am I right?
Yes, you are.
And you know the first law of thermodynamics. What is our first law of thermodynamics? This is our first law of thermodynamics. When you substitute this change in internal energy is equal to 0 here, then you will get Q, which is equal to W. Am I right?
Yes.
And we have the formula for isothermal work done. What is the formula? W, which is equal to N RT, natural log of Vf over Vi. So I can directly substitute the formula here. Am I right?
Yes, doctor. Clear.
So after you substitute the value, you have to substitute the value in the given formula, and then you have to see the answer. If the answer is positive, it clearly says the heat is transferred to the gas. If you got the answer as negative, your heat is transferred from the gas. Understand?
Okay, so the isothermal mean the energy equals 0.
Internal energy is equal to 0.
Yeah, okay.
Doctor,
Thank you.
Clear? My dear, I wrote all these things here. You can see here. You can just see this. Here, I wrote everything here. You can see what is the case for isothermal. Internal energy is equal to 0. Am I right? What is the case for adiabatic?
Q equal to 0.
What is the case for a constant? That means isochoric. Your work done is 0. Am I right? That means this is constant volume. Am I right?
Yes.
And what is the condition for constant pressure? This will be the condition. So if you know these things, my dear, if you go back to your chapter number 18, the last slide we gave this information. Am I right?
Yes.
Special
Yes.
cases. Do you remember that? I gave the slide name as special cases.
Yes.
Yes.
So go back to chapter number 18. Have a look. Clear?
Doctor,
As the thermal, the change of T is equal 0, right?
Change in internal energy is equal to 0.
Okay. I'm wrong.
Yes, brother.
according
Any other question?
to the last question,
Okay.
if the work is positive, the surroundings will be negative, right?
If the
work is positive, then the surroundings will be negative
how you can say surroundings will be negative?
because the work takes the heat from the surroundings.
Idea heat is transferred. That information is not given. How the heat is transferred from the surrounding? Because when you studied the concept of thermodynamics, you have to remember two things: system and the environment. Am I right?
Yes.
So either if the heat is transferred, the object is taking heat from the surrounding to the system, or the heat is taken from the system. Only these two things will happen.
Oh, okay.
Clear?
Yes.
Okay. Okay, my dear.
Teacher.
I think yes,
Teacher,
yes.
just repeat when it's minus. It's
My dear,
transferred
if you
to the gas.
if you got the answer as positive, better again
Yeah, I know.
go back to the slide. What answer you got here? What answer you got here?
We got positive, so I'm talking about the negative.
Positive. So positive sign shows the heat is transferred to the gas. Suppose if you got negative, the heat is transferred from the gas. Clear?
Yeah, clear.
Clear, doctor.
We can leave it up.
Listen, just a minute. Understand?
Yes, Doctor, clear.
Okay, that's it. My dear, it's my kind advice. This chapter is very, very important. For sure, 1 or 2 questions will be asked for your midterm exam. And also in the final exam also, we will take some question from this chapter. So please, it's my advice. We already covered this chapter 19 and you have 2 days holidays in the weekend. Please try to work out these problems. Understand? Understand, my dear?
Yes, Doctor.
It's my kind advice. If you follow my instruction, you will get very good mark. Otherwise, I'm sorry, my dear. It's really very hard for to get the mark. Understand? So please follow my instruction. During the weekend, take a paper, solve all this question. Clear?
Yes.
Okay. Good.